Why does fire exist? Simple question. You've seen fire 1,000 times. Campfires, candles, stoves. You strike a match, something burns, flames appear. But why? Most people never ask. Fire just is. It's hot, it's bright, it destroys things. That's all you need to know, right? Wrong. When you really ask what fire is, when you dig into what's actually happening when something burns, you discover something so beautiful, so perfectly connected to everything else in nature, that it changes how you see the world. Fire is not just a thing that happens. Fire is a window into how atoms behave, how energy moves, how the sun powers everything, and why trees exist in the first place. Let me show you. Start with a piece of wood, dead trees sitting there doing nothing, and air, oxygen in the air floating around, also doing nothing. The wood has been sitting there. The oxygen has been there the whole time. Nothing's happening. They're just there. But atoms like each other to different degrees. Oxygen, for instance, in the air would like to be next to carbon. And if they get near each other, they snap together. But here's the problem. If they're not close enough, they repel and go apart. So they don't know that they could snap together. This is the fundamental tension. Carbon and oxygen want to be together. Being together releases energy. A lot of energy. That's the stable state, the low energy configuration. But to get there, they first have to get close. And getting close means climbing over a barrier. It's like a ball trying to climb a hill with a deep hole on the other side, like a volcano. The ball rolls along, but it doesn't fall into the hole because as soon as it starts climbing the hill, it rolls back down. But if you make it go fast enough, it will fall in. With wood and oxygen, the carbon in the wood and the oxygen in the air collide constantly. Oxygen hits carbon, but if it's not hot enough, it just bounces away again. The air is always coming, nothing happens. The atoms are colliding millions of times every second, but they're not reacting because they don't have enough energy. They hit, bounce, separate over and over. The wood just sits there. The oxygen just floats around. Nothing changes. This can go on for years, decades, centuries. A piece of wood can sit in the presence of oxygen for 1,000 years and nothing happens. The atoms want to react, but they can't get over the barrier. But if you heat it up somehow, somewhere, get it started, a few atoms move fast enough. They go over the top, so to speak. They get close enough to the carbon and snap together. And that releases a lot of jiggly motion, which hits other atoms and makes them move faster, so they can climb the barrier and react with other carbon atoms. They jiggle and make others jiggle, and suddenly you get a terrible catastrophe, one reaction triggering another and another and another. Everything starts moving faster and faster and snapping together. The whole system changes. That catastrophe is filed. Once it keeps going, the heat makes other atoms capable of reacting, which produces more heat, which makes still more atoms react. This is the key to understanding fire. Nothing magical happens when you light a match. You're just giving a few atoms enough energy to get over the barrier. Once they do, they release energy. That energy makes other atoms move faster. Those atoms get over the barrier and release more energy. And so on. It's exponential growth. One reaction triggers 2. 2 trigger 4. 4 trigger 8. The number of reacting atoms doubles and doubles and doubles within a fraction of a second. Suddenly you have billions of atoms snapping together simultaneously. That's why fire explodes into existence. It's not gradual. It's sudden because it's a chain reaction, a runaway feedback process. All this snapping produces enormous atomic motion. And if you put a cup of coffee above that burning wood, it gets all that motion too. That's what heat is. Heat is not a substance. It's not a fluid that flows. Heat is atomic motion. The faster atoms jiggle, the hotter something is. When fire releases energy, that energy goes into making atoms move faster. That's heat. That's temperature. That's what you feel when you hold your hand near a flame. Fire is not a substance. It's not a thing. Fire is a process, a catastrophic chain reaction where atoms snap together faster and faster, releasing energy, making other atoms move faster, which causes more reactions. It's a cascade. Once it starts, it feeds on itself. The heat from the reactions provides the energy needed to make more reactions happen. That's why fire spreads. That's why it's hard to stop. The only way to stop it is to break the loop. Cool it down below the threshold, remove the fuel, remove the oxygen, cut off one leg of the triangle, and the process collapses. And then once you start thinking, you keep going. You ask, where did this come from? Why has the wood been sitting there all this time with oxygen and not burned earlier? Where did the wood come from? It came from a tree. And the substance of a tree is carbon. Where did that come from? From the air. From carbon dioxide? People look at trees and think they come from the ground. You plant a seed in soil, the tree grows, so obviously it came from the soil, right? Wrong. The carbon dioxide in the air goes into the tree. The tree uses energy to knock the oxygen away from the carbon, pushing the oxygen out and keeping the carbon along with water. Water comes from the ground, yes, but how did it get there? It came down from the sky. In fact, almost all of a tree comes from the air. There's a little bit from the ground. Minerals and nutrients, those arrows become the ash when you burn wood. That tiny residue came from the soil. But the wood itself, the part that burns, is carbon from the air and water from the rain. Almost nothing came from the soil. You can prove this. Take a pot of soil and weigh it. Plant a seed. Water it for years. Let the tree grow large and heavy. Then dig up the tree and weigh the soil again. The soil weighs almost the same as before, maybe a tiny bit less, but the tree weighs hundreds of pounds more. Where did that mass come from? Not from the soil. It came from the air. This experiment was done in the 1600s by the Dutch scientist Jan Baptista van Helmont. He weighed everything carefully. The soil barely changed weight. The tree gained enormous mass. He correctly concluded the tree did not come from the soil, though he thought it came from water. He was close. Water is part of it, but most of the mass is carbon pulled directly out of carbon dioxide in the air. But now there's another question. Carbon and oxygen stick together very tightly. How does the tree manage to take carbon dioxide and undo that bond so easily? It's not life having some mysterious force. It's the sun. Sunlight comes down and provides the energy to knock the oxygen away from the carbon. That's why plants need sunlight. The sun is doing the work, real physical work, pumping energy into the system. The oxygen is a byproduct which the tree releases back into the air. What's left becomes the substance of the tree. This is what makes life on Earth possible. The sun pushes systems away from equilibrium, creating order out of disorder, building structure. Trees are constantly doing this, pulling carbon dioxide out of the air, tearing it apart, building themselves from carbon, releasing oxygen. That is photosynthesis. Fire snaps carbon and oxygen together. Trees use sunlight to rip them apart, to store energy, to build structure. And that structure, that's potential energy. The carbon and oxygen are held apart. They want to be together, but they're separated. Energy is stored in that separation. Then when we take the substance of the tree and put it in the fireplace, and there's all this oxygen made by trees and all this carbon, they would much prefer to be close together again. Once you let heat get it started, the process continues, creating enormous activity as everything goes back together again. All this beautiful light comes up. Everything is being undone. You're going back from carbon and oxygen to carbon dioxide. And the light and heat that come out, that's the light and heat of the sun that went in. It's stored sunlight coming out when you burn a log. Think about that for a second. The tree spent years collecting sunlight bit by bit, photon by photon, using that energy to pull carbon out of the air and build itself. It stored that energy in its structure. Then you cut down the tree, let the wood dry, stack it in your fireplace. And when you light it, all that stored sunlight comes urine back out. The carbon that the tree worked so hard to separate from oxygen is collapsing back together. The energy that was stored is being released. Fire is just stored sunlight escaping. A log burning in your fireplace is the sun shining again. The light you see flickering in the flames, that sunlight fell on leaves 5 years ago, 10 years ago, 50 years ago. It was stored as chemical bonds and is now released all at once. Every photon from the fire is, in a sense, a recycled photon from the sun. The energy is the same. It went in as sunlight, got stored as structure, and comes back out as firelight. Now you might ask, why doesn't the wood just spontaneously catch fire? If carbon and oxygen want to be together so badly, why do you need to light a match? Because of that hill I mentioned earlier, the activation energy. At room temperature, the atoms aren't jiggling fast enough to get over the hill. They're bumping into each other, but they're not reacting. The wood and the oxygen are stuck in what we call a metastable state. They want to react, but they can't get started. It's like a boulder balanced on top of a hill. It wants to roll down, that's the lower energy state. But it's sitting in a small depression at the top. It's stable as long as nothing pushes it. But give it just a little nudge and it rolls down, releasing a lot of energy. That's what the match does, it provides the nudge. It heats a small region of the wood, making those atoms jiggle faster and G. ET over the activation barrier. Once a few reactions start, they produce enough heat to trigger more reactions and the fire spreads. This is why things don't just spontaneously combust. The universe is full of metastable states, systems that want to release energy but can't get started. Wood and oxygen, gasoline and air, food and oxygen in your cells. They're all waiting for a trigger, a spark, an enzyme, something to get them over that initial barrier. And once they start, they run on their own. Here's another thing that should blow your mind. The oxygen in the air, where did that come from? From trees, from plants, from photosynthesis. For billions of years, plants have been ripping carbon dioxide apart, keeping the carbon and spitting out the oxygen. All the oxygen you breathe, all the oxygen in the atmosphere, it's waste. It's a byproduct. Plants don't want it. They throw it away. The early Earth had almost no free oxygen. The atmosphere was mostly carbon dioxide, nitrogen, and water vapor. Then photosynthetic organisms evolved, and they started dumping oxygen into the atmosphere as waste. For them, oxygen was poison. Early organisms died when oxygen levels rose. But some organisms evolved to use oxygen to burn food with it, extracting energy. And that oxygen is what makes fire possible. Well, here's the cycle. Sun shines. Plants use sunlight to break apart carbon dioxide, building themselves out of carbon and releasing oxygen. Animals, including you, eat plant souls, or eat other animals that ate plants. And you burn that carbon, combining it back with oxygen to release energy. That burning happens inside your cells. It's called respiration. It's the same process as fire, just slower and more controlled. You're taking carbon-based molecules and combining them with oxygen to release energy. The carbon dioxide you exhale is the same carbon dioxide plants absorb. It's a cycle. Sun to plants to animals and back. Carbon circulating, oxygen circulating, energy flowing. Fire is just that cycle sped up and made visible. When you burn wood in a fireplace, you're doing exactly what your cells do when they burn sugar. Same reaction. Carbon plus oxygen makes carbon dioxide and releases energy. The only difference is speed and control. Your cells do it slowly and carefully, capturing the energy in useful molecules like ATP. Fire does it all at once, releasing the energy as heat and light. But it's the same chemistry, the same process. You are, in a very real sense, a slow fire. Let me make this even more concrete. When you burn wood, you're converting chemical energy into heat and light. That chemical energy was stored in the bonds holding the wood's molecules together. Those bonds took energy to create. That energy was sunlight the tree absorbed, breaking those bonds and forming new bonds, carbon dioxide and water. Releases that energy. The heat you feel is atoms jiggling faster because energy was released. The light you see comes from atoms and then molecules getting excited, literally electrons jumping to higher energy levels and then falling back down, emitting photons. When carbon and oxygen snap together, the energy release doesn't disappear. It goes into motion. Atoms moving faster, molecules vibrating, electrons jumping to higher orbits. And when those electrons fall back down, they emit light. That glow is the fire. That's the flame. Different atoms emit different colors. Sodium makes yellow, copper makes green, strontium makes red. That's why fireworks work. Different chemicals burn with different colors because they have different electron configurations. The smoke is tiny particles of carbon and other material that didn't fully react, floating upward because they're hot and less dense than the surrounding air. The ash is the minerals, the stuff that wasn't carbon, the tiny fraction of the tree that came from the soil. Everything else, the carbon, hydrogen, and oxygen, has turned into gas. Carbon dioxide and water vapor, invisible products floating away. The mass didn't disappear. It became gas and drifted off. Now here's the question you should be asking. Next question. How is it that the sun is so jiggly, so hot? That's a different story. I've got to stop somewhere. I'll leave you something to imagine.